Hi, welcome to my channel. My name is V, co-founder of Kubanari. You can find me on Twitter, Instagram, and we have a Discord. Join me and we can talk about game dev, food, cats, or my new game, a life simulator set in a magical academy where you're a witch or a wizard student. In this new episode, the adventures of the sneaky robot continue, and today we're gonna see how to create a deadly laser. For this implementation of the deadly laser, we have three main things. We have to modify the animation blueprint of the robot to add a new animation. We need particles to represent the deadly laser. But keep in mind, I'm not an artist, I'm a programmer, so my version of the laser is very simple. So don't expect too much there. But the gameplay is gonna be there. And finally, we also need somewhere to put that deadly laser, and that's why I have here this element to represent this blueprint, which is an actor C++ class, which we also need to implement the logic of the character stepping in and the character falling or being dead. Let me show you the main character, the robot character. We don't need to do anything right here, but what we need to change is the animation blueprint, which is this one. Okay. If you remember, on the last video, we left it with, we had the locomotion for the character to move around, the stealth mode is also included on that locomotion, on that blend space. Then in the next episode we added the look at animation, so we added this part, and now we need to add animations. So for that, after this node, we're gonna use a blend pose animation type, a blend pose based of this enum, which is a custom enum that I'll show you where I implemented this enum. We can use other things like state machines, but I decided to go this route because this character is quite simple, it only have a few things, and with this blend space and using this enum, which I really like to use enums, it's more than enough. So the final pose, it will go through all this flow, and depending on what happens, it will perform one thing or another. Okay, let's take a look first at the e-animation type on the code. That enum is declared on definitions.8. I usually use this type of this is a class that contains nothing. And I usually put these enums in this place because it's easy to reach from other places and there is no much code, so it will be easy for the compiler to link everything together. And as you can see, I have the E in animation type, and I include this full animation, which is the animation that we are going to use. I also have more animation. This is for the future. We have a dismiss gesture, we have an interact and push. This will come in the future. For now, we just need to do this. Let's go to robot anim instance, that, if you remember, is the class that is the animation blueprint extends from this class. So I can set this type of enums through code or access from the animation blueprint. For the animation, I have this U property, which is that enum, and then I have a setter and a getter. I'm gonna specifically use this set on the character and other places to change the animation. If we take a look at the animation blueprint again, we can see that the parent class is the robot anim instance, and right here we have all the properties that extends from that class. Specifically, we have this current animation. If you can see all of this, it's because you need to tick this option, show inherit variables. Okay, so how do we use this? So basically, when the animation blueprint reaches this point, before we have this right there, right? Now we want to combine all of that together. So the way we do it is simple. We just need to type right click, blend poses, and go through all this list. The one that we are interested in is this blend poses by E animation type. And there we go, we have that one, and as you can see we only have the default pose. You want to add more pins, all you have to do is right click and add the pins, which are exactly the same as the enum. And we want the full. Okay, we also need the none, because if this enum animation type is none, what we want to do is the previous things. So all of that. The locomotion, the look at, well, the look at will be combined with the rest of the animation. But why not? Because I decided in my case that if I'm performing an animation, I don't want the robot to move or perform other elements, just the animation. Now we can set this default just in case. It's not gonna play, so I have a play idle in this case. It's not gonna do anything because really the idle is set on the blend space, but that's good to have just in case. What we want is the full pose, which I have the play dying backwards. You can select any other. Those animations are from Mixamo, remember, because this rig is from Mixamo. After that, we just need to set that there, and it will go through that state. Okay, I'm gonna remove this. Okay, we need to have the current animation with a getter right there. And compile, and yeah. With this, we can combine animations and add other type of IK or procedural elements. Okay, for this play dying backwards, which is that one, Unreal, what it does is usually set this to loop. I don't want to loop, so just like loop animation to none. And I'm gonna do this faster, like 3, because this is kind of a slow animation and I want this to be faster. Okay. So now if we play, we have the locomotion, the stealth, we can still run, and if we go straight to it will do the fall. So we're combining everything together. Second element, the deadly laser. So this is my representation. I have this static mesh, and this is a collider. So if I open the blueprint, you will see that I have 2 static mesh for that, and a beam collision, which is the collision that I'm using for the robot or any other character. In the future, in the next video, probably we will have a box that we can push, so we can escape from this deadly laser. And in this animation blueprint, we have several scene components. This is the root. As usual, I like to do this way, so I have everything on that element. And then I have a beam source and a target source. I'm gonna use these two for the particles. And in this laser beam crossing, I'm using as a element this beam particle system because I need to adjust the laser by code when something is in between the laser. For the particles of the laser, okay, let's play again. You can see have this like greenish type of laser. We need a few elements, which is a particle system and a material. Okay, so that's my particle. The way you do this is right click, a new particle system. Okay. This is what you see. I'm not gonna go in detail to this, but I'm gonna show you the basics. So I'm gonna open my version, which is already prepared. And important things, we need the material for the particle, and then we need to go through all of these elements, so I'm gonna go quickly. Okay, here we have the particle, the material, spawn. I have set this way. Okay, lifetime is in infinite. You will normally have something different. Okay, lifetime, you will have this as a default, so set it to 0, 0. Initial color, I've got this. No, don't think I'm using this one, no. Okay, let's move on. Initial velocity, everything 0, 0, 0. Initial size, that's also important. I have distribution vector uniform, and then I have these values. You can play around with this. I spent quite a lot of time to adjust all of these so it looks exactly the way I want it to look. Okay, color over lifetime, which you wouldn't normally have. Oh yeah, no, you have that, sorry. And so I set these values, which is a gradient that looks very nice. This is the color that I like, and it looks okay on my scene. So just need to go through all of these and play around with these elements. I'm not super fan of making particles. It's quite a lot of work, and it's not my favorite task, to be honest. Okay, but specifically what we need for the laser is something important. Apart from the material, we need to set this beam data. So the way you do it is in this blank space, save data, and then you select beam data. With this, you have access to source, target, and noise. So we need to add those things, and we can find that on the beam. And then you have target, you have source, and you have noise. These three elements, specifically target and source, are important because we need to access them from code. Okay, let's go back to my version and I'll show you a few things. Okay, this one, beam data, has to set to target. And then I've got all of these as well. Distance, 1000, so yeah. Then in source, take a look at the parameters. So I have distribution vector constant, and this is important. The source has to be emitter because the beam source is where the laser starts. And this is the name I'm using, and just set that same name. For target, I have something similar, and in this case I have user set because I'm gonna use this on code, so that's important. And beam target, important as well. The rest I have 200. As I said, I spent some time on adjusting all of this. And finally, noise, which will make some noise and it looks nice. I don't think it's very, very important. But you can see what I have. Noise range with several values. Then I have all of this. The material. Let's go to the material and let's take a look. So the material has some mathematical operations, but it's not very complicated. I also had to take a look at this. So as I said, I'm not an artist, so this is really dry. Okay, this is important. This node is important because if we want to change the color of the beam, we need this object right there. And this is to set the color, this color over lifetime. We take this particle color if we right click and then particle color. There. Okay, that's the one. Okay, the material has to be set as translucent and unlit. And if we do these operations, first thing is take all the pixels with text code node. That's the text code. Text core. That's the one. We will get this one. And this is basically a scan of all the pixels on the material. And then we want only to mask all of that to this channel, the green one. And when you have pixels, what you get is RGBA, and we are only interested in the G one. And then after these several operations, multiply to increase the brightness of the pixels, and then assign. I'm not so sure what it does. It was also a test, but combining these three together and multiply with the color will give us this type of effect, which is kind of translucent, and it has this on the top. It has some alpha, and on the bottom it will have also alpha. We get this, so it's nice. It has some small alpha, then has color, and it combines with this gradient. Okay, so we have the multiply right there for the color on the emissive color, and finally the alpha also uses all of these operations on the opacity, and we get this. Let me show you the whole thing. Okay, right there, and again, don't forget to include it here. So just select the beam, and that's it. And we are set for the blueprint. Okay, if we go back, don't forget to set it in this laser beam crossing, which is the next part, which is the code. The beam is an actor class, C++ class. And as you saw in the blueprint, we have the several using components, the root, the beam source, which we'll use to switch to set the source and the target of the beam. Here we have target and the collision. In the constructor, we have all of those elements set. For the collision, which is this U-box component, we have, as usual, a begin overlap and end overlap functions for when something steps inside the beam. Important to set them as a U function, otherwise it won't work and you will have an error. As a U property, we have the beam particle. This is the component, the reference component that we need for access properties on the beam particle system. You will see why. Finally, we have a few other properties, which is for the beam target and beam source. This is the current target point, and this is the in local space for the target and the source. Okay. If we go to the begin play, the first thing needs to happen is we need to spawn emitter at location. We will spawn the beam, and we will take a reference. For that, we use the beam particle system, and we spawn this in the get actor location, which is on the blueprint, on the center of the blueprint. After that, we need to set the source and the target. For that, we can use this component, and we have two methods: set beam source point and set beam target point. A few important things right here. One of the params that we need is this. This is an index. It's an emitter index, because in the particle system we can have different emitters, and in this case we are using only the first one, which is the 0. So this is one of the emitters, but you can have more, so that's why this is 0. This is for this one. And we are accessing source and target. Okay, next thing, I'm just getting a reference to the location of the beam source, and what I'm doing is I'm getting the source, the scene location, which is this one, is US scene component, and I'm transforming the position into local space. because when the character steps in this beam, we need to have everything on the same local space. That's why I'm doing this operation. We get the transfer of the actor, and we do the inverse transfer position, so we can get the local position, not the global. If we use this, it will be global. The same thing we do with the current target point, which is based on the target source. And we have here the same operation, an inverse transform position. Okay, next thing, and everything comes together in the begin overlap for the trigger. Okay, so here, first thing we do is to check for the actor. Important to always have this type of checks on Unreal, because otherwise it will crash. So I usually go check everything if everything is null, but null pointer. Okay, next thing is we get the other actor. In this case, it's probably gonna be the character because we don't have any more actors. And we get the location, and we again set this. We use the transform to get it the local space, the local of this, not the wall, because we have this in local, this in local, so the calculations are gonna be correct if we used everything in local. Okay, we still check. We check if the other actor is inside the beam. For that, we use the local source and the local target. If this happens, this means the actor is not outside but inside. As usually, we need to do a cast because we want to change the status. This change status, we call this new animation, and the character will perform the fall. Let's go to this change status. That is super simple. It's just don't worry about that. That's just a check for me. We have current status, which is another enum. But what is important here is I'm checking. Okay, if the current status is falling, we lock the input, so we won't move again, and we call animate with the fall. The animate function, all it does is just, well, I have another check here. Don't mind that. What we need to do is to set animation, and this will talk to the animation blueprint and send to the current animation type this animation, and it will do the fall. So everything comes together right here. Let's continue. Okay. Now the character is in the middle of the laser, or is in between. So we need to calculate again what is the target for the beam. We do this with the distance of the target location and the other, everything in local. This is the distance that we have left for the beam. Okay, we need to recalculate the current target, and we use the get forward vector just in case we have the laser rotated 90 degrees. With this simple calculation with the forward, the distance, and the current target, we can see what is the new target location for the beam. We set this again to local to keep the reference, and finally we set the target point. And that's it. You can adjust the size of the beam this way. Finally, the end overlap, which in this example doesn't happen because the character dies and nothing ever happens. We can move the character, but what we do is basically reset the beam, and we reset the beam. I again have this check because this is probably for the next video, but it's to check that we are still in the middle of the beam with the same check. If that happens, what we do is set everything to the original position. Okay, let's test this out. Let's play and let's move around with the robot, and he's dead. Okay, so as you can see, This is the laser. This is the point exactly where this guy falls. And the size of the beam, it is adjusted. If, for example, I go closer to the source, it will also adjust that. So this is pretty cool. Okay, after this guy falls, what we could do, we could wait like 5 seconds and maybe reset the beam. But well, you can do this yourself, so you can learn a little bit. And that's it for today's video. And the next video, we're gonna implement the push mechanic where we can have the robot pushing a box and put in the box between the lasers so he can escape. Don't forget to subscribe to my channel, like, share, it helps. And remember that I have a Patreon page where you can support me and also get the project files. And I also have the written version of this tutorial if you support me. Thanks for watching and see you next time on the next video. Bye!